Alrighty. Well, good morning, good afternoon, good evening, wherever you are coming in from. Welcome to Sumo Logic's Customer Brown Bag series. I'm going to get things kicked off real quick for us. My name is Lisa Carnes, and I am one of our CSMs here at Sumo Logic. And if you haven't been to one of our brown bags before, we typically do them on the second, third, and fourth Tuesday of every month. And each of those Tuesdays has a certain topic that we cover. So today's topic is going to be focused on observability. And I'm excited to have one of our principal solution engineers, Jeff. He's going to be teaching us He's going to be teaching us tips for how to get started with Open Telemetry. And as with all the brown bags, if you have any questions, feel free to utilize the chat. I've opened it up for everyone, or you can use the Q&A. I'll be monitoring your questions and then letting Jeff know when things come up as they do. And just as a reminder, these are sessions that are meant for our customers to have an intimate setting with a Sumo Logic technical person. So please don't be afraid to ask questions, or if you need him to repeat something or redo or go over something, he can totally do that. And it's going to be awesome. So without further ado, I will go ahead and kick it off to Jeff.
All right, thanks, Lisa. Give me 1 second to share my screen. Sorry, 1 second, technical difficulties.
It's all good.
All right, so we're gonna do desktop 1, and we're gonna do slides and slideshow. Okay, can everyone see the screen?
Yep.
Awesome. So I just have 96 slides that we're gonna go through. So buckle up. No, actually, I just have a single slide, and I'll go ahead and kind of build it out here. So the purpose of this presentation, we're going to get into talking about Open Telemetry and walk through some examples of how to quickly get started. So let me just set the stage by defining Open Telemetry. So if you're not familiar with it, it is the second most popular CNCF project after Kubernetes. And that was not the case a few years ago, but the accelerated adoption that we're seeing with Open Telemetry and the critical mass and the community of developers, from end users to vendors to, you name it, it's been pretty cool to see and participate in. So what does it get you? Well, it really gets you 3 signals for the price of 1. And by that I mean, in the past, if you wanted to analyze logs, metrics, and traces, you needed to wrangle an array of technologies and different collection methods, and there were no standards, and vendors sort of contributed to the confusion by providing their own best practices according to them, and proprietary signal formats and proprietary collection methods, etc. So with Open Telemetry, you're able to use one standard for both the signal generation, the content of the signal, and by signal I just mean a log, a metric, or a trace, and then as well as one standard for how to generate those signals from your apps, how to collect them and aggregate them and transform them, and how to transmit them to your telemetry backend of choice, which could be Sumo Logic, it could be another vendor, commercial solution, it could be a set of open source tools. So you really are benefiting not just from kind of doing the work to define your standards one time and get all 3 signal types for complete observability, which is the goal, but you're also able to do this in a non-proprietary way that makes your work really future-proof and portable. So you're able to quickly evaluate different vendors. You're able to move from kind of off of an open source stack into a commercial vendor very easily, or vice versa. And then lastly, OpenTelemetry has really broad support. So it supports your apps. And I've italicized your apps and your compute here because I do mean your apps and compute. So very likely the languages that your custom apps are written in have instrumentation libraries and including including auto instrumentation, which makes it really fast to get started. And then similarly, in terms of your compute, the Open Telemetry collector itself is supports running on ARM. It supports running in containers on really a variety of container orchestrators like Kubernetes. You can instrument your Lambda and Azure functions and cloud functions. It even runs on Windows. So chances are you are able to actually get started right now. There are really no kind of technical barriers. So what do you do to stand up Open Telemetry and really operationalize it? While it's easier than it was in the pre-OTel world with all of the kind of competing standards for all of those moving parts, it's now you sort of have one ecosystem to play in and deal with. So you instrument your apps, you get your apps to generate these signals. You then collect those signals, and you can do things like process them and transform them and modify them, etc. And then step three is really where something like Sumo Logic comes in, and this is where you're analyzing the collected signals in a telemetry backend of your choice. So while easier than the pre-OTel world, there's still a lot of moving parts, right? It's not just easy, although it is significantly easier than it used to be. So what I have personally found helpful in my own journey of learning about OpenTelemetry is to look at some examples. And it turns out there are some great example apps out there, including the one we'll look at today, which is the official Astronomy Shop OTel demo app. We'll look at this kind of in the raw, so to speak, and actually interact with the Astronomy Shop app. Then we'll actually use Sumo Logic to analyze the signals generated from the Astronomy Shop application. And then lastly, we'll talk about how you can get up and running with the Astronomy Shop app in Sumo Logic, like with your Sumo Logic org, using something called QuickLab. So that's kind of the agenda for today. So let's before we say thank you and bid you adieu, I'm going to get out of slide mode. I told you I just had one slide, Lisa. All right, so let's take a look at the Open Telemetry demo app itself. So it is a fake e-commerce site. You actually are not able to purchase hot products like telescopes and expensive lenses and binoculars, but you can sort of pretend to, right? Which is fun. So if we want to buy a really expensive telescope, I can add it to my cart, right? I have my fake address information already filled in for me. I can place my order, and then I can continue shopping. So I can do things like generate some traffic and some transactions within the app. In terms of the app architecture itself, right, fully documented out on opentelemetry.io, right? So you can click the demo section here. And when I say that this is a really great example for getting started with OpenTelemetry, this lets you really look at the examples for instrumenting apps and services written in different languages. So you can see here, we've got all of these different microservices that make up the e-commerce site, including our cart service, our accounting and checkout and product catalog services, our front end. We even have a fraud detection service. So if you've got languages or apps written in PHP, Python, Ruby, Rust, even C++, right, which is our currency service, right? You can take a look at how the instrumentation was done inside the demo app. And you'll notice that there are some of these services are, and this is intentional, making use of out of the box instrumentation libraries. Others are doing things the more manual way, where you have much more control over the type and makeup and content of the signals that are being generated, but slightly higher level of effort. So you can see all of these different examples, and it's pretty fun to play with. So each service itself is also fully documented, and there's a couple of nice scenarios here where you can generate fault conditions by enabling some feature flags to create some chaos. In terms of the architecture itself, this is worth spending just a minute on. You'll see that we've got all of our microservices. They're a mix of gRPC and HTTP-based services. You'll see we've got some pub sub with Kafka. We've got some caching with Redis. We've got our Postgres database, right? So we have a number of different moving parts, really high level of realism here. And frankly, this makes a great learning tool for actually learning about these other technologies as well, not just Open Telemetry. So all of the traffic hits the front end by way of this front end proxy, which is of course Envoy. And there's really two things upstream of our front end proxy. One would be a load generator, which is generating a certain amount, kind of low level of transactions, hitting predefined routes. We'll take a look at that service in a minute. And then we've got end users that might connect to the service via the internet, which is what I'm doing here. So how do we actually get started? And I'm going to try to keep an eye on the chat as well.
Oh, that was, I was just giving them the 2 links.
Oh, perfect. Thanks, Lisa. So yes, yeah, I appreciate that. And let me know, Lisa, if there are any questions as I'm going here. So
For sure.
So let's take a closer look at the feature flags that are available to us. So you'll see here we've got actually 4 feature flags. They are generating different types of fault conditions. So every so often, right, a get product call to a particular telescope product ID will fail, etc. You can inject memory leaks and so on. So pretty fun to actually stand this thing up and generate some problems, and then look at those within something like Sumo logic. So we can actually do that here. And look at the feature flag service. Right now, I have them all disabled. So I'm just going to enable them and set them all to true here. The other thing that we noticed that is part of the app is that load generator service. So if we don't want to spend time clicking around on the site, we should be able to actually hit the load gen service. You do need the trailing slash if you're trying to play along at home. And you'll notice we have, Locust is an open source load generator that generates traffic to pre-selected routes, so you can sort of come up with a test routine. You'll notice here we have 100 users that have been generated. We have a request per second rate of about 26, 27, and we've got about 1% failures. So if we wanted to stop this test and make a new test, we could go crazy and say, let's make 1,000 users and let's do a spawn rate of let's do 50 per second, something like that. And we'll start swarming. And so now our stats have reset, and we can see our transaction count is skyrocketing along with our failures as load is being added to the front end and the other various services that are represented here in the different routes. So we can see different product catalog IDs being accessed and so on. So so now let's talk about what the astronomy shop looks like within Sumo Logic. So if I switch over here from the demo to Sumo Logic, and I'll refresh my services list, you'll see I've got, now that I've started swarming my app, I have tons of errors in a bunch of services. So classic Sumo Logic service map, right? We also have, of course, the list of services where, so all of the different services represented in the Astronomy Shop app that we saw in the architecture diagram show up in Sumo as a result of trace data being collected automatically. And we can do something like pick on a service, look at KPIs like we do. We can see all of the related entities for this astronomy shop application. And in fact, Sumo Logic is able to tell me that this is an app that is a Kubernetes-based app. And I can see information about that front end microservice, like what Kubernetes pod ID it it's running on, the service itself, the deployment that's managing those things. I've got some information about the Kubernetes worker nodes, including their internal IP address. And for each one of these, I've got some stats that are really helpful for me to understand the health and performance of these different entities. I also have some information related to the AWS infrastructure that the my EKS cluster is running on. And so, we can see things like the EC2 instance ID. And if I had the CloudWatch data coming into Sumo, then I would get the CloudWatch metrics there as well. So once I've got, all of once I've gotten myself oriented, now I can do something like look at a traces query for all of the front end services transactions that are hitting that front end. So here I've just drilled down into a traces query, right? And if I wanted to open my aperture back up, right, I could do something like look at all of the traces for that particular instance of the application. And you can see really my swarm has kicked in fully, right? And my transaction rate has skyrocketed, along with my average duration for these transactions. So you can see the longer bars here indicate, right, where our user experience has degraded. We're close to 1.5 human seconds for end-to-end completion for our checkout service, as an example. So a little bit about how you can use Sumo Logic to understand the performance characteristics of the application, including not just what's happening on the back end, but what's happening on the front end from an end user experience standpoint as well. So notice here we have a service called front end rum, right, which connects directly to Sumo Logic's real user monitoring view of the world, right? Where you can see all of the things like XHR requests, long tasks, et cetera, broken down by browser, by geo, et cetera, all of the navigation timings, right? And you can see, of course, like how that, again, the end user experience degrades when the app is under load. So lots of different sort of lenses for looking at this astronomy shop application through Sumo Logic, whether that be from an APM perspective, from a real user monitoring perspective, from a Kubernetes infrastructure perspective, right? If for folks that might not be familiar with Sumo's Kubernetes observability solution, This is what's going to bring in health and performance characteristics of the cluster itself. And so we can see for this cluster, for each of our namespaces, what resource utilization looks like on a service by service basis. We have the nice inventory that Sumo Logic populates for us automatically, and so on. So how do we get started with the Astronomy Shop application and Sumo Logic? Well, let's go back to the documentation. So if we take a look briefly at the demo app documentation, you'll see that we can run the demo in Docker on our laptops, or we can run it in Kubernetes. And you'll notice the Kubernetes deployment has lets you install it by referencing a Helm chart, which is great. Folks might be wondering, or might who are familiar with Sumo Logic, will recognize that the Sumo Logic Kubernetes observability solution also is installed using a Helm chart. So looking at Sumo's Kubernetes observability quick start, we can see we're essentially going to add the Sumo Helm repo and then deploy the Sumo solution also using a Helm chart. So we really have two Helm charts to install. But you'll and this, you may have already gone down this path if you have your production Kubernetes clusters that you've instrumented and set up collection on to monitor them within Sumo Logic. Sumo Logic has gone a step further and actually combined the Open Telemetry demo application Helm chart with the Sumo Logic Kubernetes observability Helm chart. So really bundling them together. And one of the main reasons that we chose to get on this path is there are some things that Sumo Logic users aren't going to be super interested in. So you can actually see them here on the architecture page. You'll notice there are services for Prometheus, Jaeger, and Grafana, right, which come out of the box in the upstream OTel demo app. And those are fine solutions, but not really necessary or probably interesting for a Sumo Logic user. And so Sumo has made some optimizations to strip those out. We've also added in the real user monitoring component, which I just demonstrated within Sumo. So on the Sumo service map, you'll actually see a front end RUM service here as well, which is not included in the upstream app. So that's what lets us really demonstrate kind of the full capability of the Sumo solution. So to get started with the Astronomy Shop within Sumo Logic, what you can actually look at is the Sumo Logic fork of the OTel demo app. And I'll go ahead and paste in that link to the chat as well. And I'll make sure I paste it in for everyone, not just hosts and panelists. So you'll see that Sumo has actually forked the Open Telemetry demo app and making the changes that I just outlined. Okay, so now with the Sumo Logic fork of the OTel demo app, if we take a look at the Kubernetes deployment instructions, you'll see we just have a single Helm command to run. And this is, you can sort of think of this as the combined Helm chart that includes both subcharts, both the Sumo Kubernetes observability solution and the OTel demo app become subcharts here. You have the option to use it with and without real user monitoring. I would recommend with for folks, especially that haven't had a chance to play with this before. And yeah, there's a lot to kind of dig into and look at. Let me pause there and see if there are any questions.
And if anyone wants to come off mute, just raise your hand, and if that's easier to ask your question that way.
Yeah, definitely. Okay.
Yeah,
I've
no questions.
I've successfully put everyone to sleep. So
Or
uh,
you're just doing so good at explaining things that there are just no questions.
so for folks that might suffer from insomnia, you can replay this recording at night as a sleep story. It functions that way as well. Uh, so let's. Oh, I see a hand raised.
Let's see. It might have been on accident. Sometimes that happens.
Okay, no problem.
Yeah, because it would still be raised if it was legit.
Okay, so folks that are familiar with Sumo's Kubernetes observability solution are probably at this point wondering, okay, so Jeff, I'm already using Sumo to monitor my Kubernetes clusters. I love it. And um, so how do I actually does it still make sense for me to deploy the fork of Sumo's fork of the Hotel demo app in order to get my hands on this thing and start playing with it? And I would suggest actually probably not. That you would want to go ahead and use the fork, but the issue to be aware of here is because it does already include the Sumo Kubernetes observability bits, you're not going to want to deploy this Helm chart into a cluster that where Sumo collection is already installed. You're going to want to do this into a fresh cluster. Um, maybe one that you've just minted for the sole purpose of deploying the Astronomy Shop app and playing with it. And so, okay, this presents good guidance, but it presents a challenge of, well, what if I don't have a cluster, right? How can I make a cluster quickly? And this is where something called QuickLab can help us out. So if you were to go down the path of following these deployment instructions, you would notice at the very end when you actually access the app, the instructions have you forward traffic to port 8080 on your local workstation with a simple kubectl command. So just redirect traffic to localhost 8080, right? And some folks might have noticed, this. What if you don't want to do this, or you want other options? So some folks might have noticed I actually have been interacting with the um, the Astronomy Shop application here using an internet-facing load balancer. And if folks want to actually, click around and get their hands on this, and during the webinar right now, I've just thrown the public DNS name for my load balancer into the Zoom webinar chat, and folks can click around and buy a telescope. Um, so how might one expose this app publicly so it's easy for folks to play with, and build a cluster, and build a VPC or a private network to put that cluster into, and so on. Well, that's where QuickLab comes in. So QuickLab is a uh, a tool that I ended up building and releasing recently on GitHub that uh, helps folks stand up ephemeral lab environments for science projects such as learning about Open Telemetry. So QuickLab actually comes with three components that you can toggle on and off: a private network, a bastion host, and a managed Kubernetes cluster, and of course monitoring provided by Sumo Logic. So if you wanted to explore Open Telemetry instrumentation techniques, or Open Telemetry, um, you know, auto instrumentation using the Kubernetes operator, deploying it into the QuickLab managed cluster might be the path for you. If you want to play with the Open Telemetry collector and play with different config files, take advantage of the new Sumo Logic self-service monitoring flow for deploying applications from the app catalog, then taking advantage of the QuickLab Bastion host or deploying servers, Windows and Linux servers into the private networks, private subnets might be something that you're interested in. I'll just quickly navigate over to the workflow or the walkthrough guide rather for deploying the Sumo Logic fork of the Astronomy Shop app on a QuickLab managed cluster. And you can run through the steps manually, and this might be a good learning exercise for some folks, essentially creating the app and exposing the app publicly by creating a Kubernetes ingress, verifying that the associated EC2 load balancer is active, and then of course using the apps and viewing the traces like I walked through at the beginning, playing with the feature flags, right? So you can do all of that kind of manually. There's also kind of a shortcut TLDR shell script that will take care of all of that for you. That is bundled with QuickLab. So when we take a look at what we get with QuickLab, and I'm going to switch over here to a terminal window and just do a, let's actually look at sort of the switches to enable for QuickLab. So you'll notice there's a text file that contains a couple of booleans and a string value here. And this is how folks can enable and disable those QuickLab components that I mentioned. Once those are done, a simple Terraform apply will create them. And then once created, you'll see we have some information about them here, including an AWS resource group, which keeps track of all of the AWS resources related to these QuickLab components. We have some helpful sort of copy paste friendly outputs here if we wanted to SSH into our Bastion, or if we wanted to use kubectl commands against our cluster. Then we could do something like, just eval the cluster kube config output and then get our cluster info. And then we can interact with our cluster. And we can take a look at, say, all of those Astronomy Shop pods, right, running in our cluster. So lots to play with, sort of easy to get started with something like QuickLab. And let me just conclude with a quick tour of sort of the QuickLab resource group itself. So as those QuickLab components of the network, Bastion, and cluster were created, they were added to this resource group, and you could filter by component. So let's say we could look for our component tag and just look at everything with the cluster component. And you can see here we have our EKS cluster itself. We've got a log group from the EKS cluster. We've got a couple security groups related to the cluster. So within Sumo Logic, we can actually see all of that stuff too, related to the QuickLab infrastructure. So one of the things QuickLab does when you enable monitoring is installs some apps from the app catalog, including things like CloudTrail, Cost Explorer, VPC flow logs, and the EKS control plane app if you have the QuickLab cluster enabled. And here, for instance, we could look at our user activity right, from a CloudTrail perspective within Sumo Logic. Or we could look at, VPC flow logs for network traffic that's hitting that QuickLab private network, and so on and so forth. If we wanted to look at those control plane logs, right, of course, we could look at something like the EKS API server audit dashboard that comes with the Amazon EKS control plane app. So this is yet another way that folks can leverage Sumo Logic to not just learn about OpenTelemetry, but to learn about EKS, to learn about VPCs, to learn about their AWS costs, and so on and so forth. So all of the kind of window dressing and dependencies around deploying an app on a Kubernetes cluster. So I'll conclude there. That was all of the content that I had prepared. And so now we can proceed to our
Thank you.
thank you slide. But just to sort of recap, right? In the presentation today, we did talk about what is OpenTelemetry. We talked about the process for getting started with OpenTelemetry and what's involved, what to think about in terms of getting your app to generate signals through instrumentation, collecting those signals using the OpenTelemetry collector, analyzing them with the telemetry backend like Sumo Logic, and then lastly, walking through some examples of the official OTel demo app, what it looks like to monitor that app with Sumo Logic, and how you can take some baby steps toward those outcomes using QuickLab.
Jeff, did you want to also share the blog that you showed me yesterday?
Oh, yes. Thank you for reminding me, Lisa. So yes, during on the topic of using the OpenTelemetry demo application with Sumo Logic, there's a great blog post that I'll throw in the Zoom chat here that talks about the Sumo fork of the OpenTelemetry demo app. And so for folks that are interested in focusing on the Sumo fork and not the upstream OpenTelemetry demo app, then this is the blog post for you. And there's some nice setup instructions for both Docker and Kubernetes. And these are really the instructions that shell script within QuickLab is automating and just handling for you. So, but if you want some details on behind the curtain and what is required, particularly to get the real user monitoring pieces going, then this is a good blog post that walks through what would normally be an additional manual step and what you get when you take that step. So yeah, thanks Lisa for reminding me.
Mm-hmm. Awesome.
Okay.
Thanks, Jeff. That was awesome. So, well, we are certainly not going to stay on for the next 20 minutes unless there's 20 minutes of questions. We will give you back your time, but we will wait here for another 1 to 2 minutes in case you're typing a question right now, or if you want Jeff to review something. Let's see. Oh, I definitely learned a lot of capabilities I was unaware of. Oh, awesome. Thank you, David.
Yeah, thanks, David. Good feedback.
That's the point of these. So that's really good feedback. Thank you. And if there's any other nice comments for us, feel free to put that in the chat too. Or questions as well. We'll hang out here for another minute or two, just in case. Also, we put these recordings up on our YouTube page, so I will put that in the link as well. And I have finally gotten the hang of sending thank you for attending emails after these sessions, which also includes the recording. Finally getting better at learning how to deliver these sessions monthly for our customers.
Lisa, I have a question for you.
Sure.
What is coming up next in the brown bag series?
We are going to be focusing on logging. And actually, I'm really excited because we are going to have a product designer who is going to create an application, and he is going to teach our customers. For when he first started Sumo Logic, there was a learning curve that he went through. And by creating this application, he was able to learn how to better analyze data and just understand how Sumo worked in the first place for logs. And so it's going to be a little bit of a different spin, but I'm excited to have him come on board. And he's the first person on a designing team that we're having teach, but he's a big part of the things that we do with how to improve our logging with Sumo. And a quick note on that is we are going to actually have that on the first Tuesday of November due to the holiday schedule. We're going to do this the first and the second Tuesday of November. Okay, we have a question actually. Let's see. I'm trying to deploy AWS Observability using Terraform, but I'm having trouble. Who should I? Oh, okay. So Sean, what I'll do is I'll find out who your account manager is, and I'll make sure that they follow up with you to help you with that. No problem there, okay? You're welcome.
And I think I'm still sharing my screen, Lisa.
Yes,
Yeah?
yes.
Yes. Okay. So yeah, what Sean is referring to, for folks that might be unaware, is the Sumo Logic AWS observability solution, and a really cool way to bring in essentially all of your AWS data into Sumo with a single deployment step. And there is a quick start here where you can run a shell script. You've got the option to go the full CloudFormation path and deploy the solution that way using CloudFormation stack sets and blast out the CloudFormation stack across all of your AWS accounts and regions. You've also got, and this is what Sean is asking about, the ability to deploy the solution using Terraform as well. And so both options are here. And yeah, Sean, we'll definitely make sure we put you in touch with your account team who can help you with your specific questions for your situation.
Yeah. Thanks, Jeff. Alrighty, any last questions? Okay, I think it's good to call it. Well, thank you again, everyone, for your time. We love delivering these sessions for you all, and hopefully they've been helpful. And we'll see you on the next one on November 7th for logging.
Thanks, Lisa.
Thanks, Jeff.